Before we begin looking at the examples, there are just a few points that you need to remember. Always start by first stating which two triangles you are working in. This should be obvious from the question. If you're asked to prove two triangles are congruent, the question should be given with the letters in the correct order. You may need to highlight the triangles if the picture is complicated. Secondly, you need to write down 3 pairs of equal sides or angles with reasons. Thirdly, you need to end with your statement of which two triangles are congruent with the letters for each triangle in corresponding order. That means the order in which the pairs of things are equal needs to match. You then state the case of congruence in brackets next to your final statement of congruency. Okay, so let's look at some examples. This first example, you're given a big triangle that's been split into 2, and it says prove the triangle NYQ is congruent to triangle PYQ. So obviously the first thing we need to do is identify what the two triangles are that I'm looking at. Now, not terribly tricky here. So NYQ we're looking at there, and PYQ we're looking over there. Now remember in your notes that you wrote down just now, it said that you should always start by writing down which two triangles you are working in. So here's the outline. Start off by saying in triangle NYQ and triangle PYQ, we're going to need 3 statements of equality, and we're going to end off with stating that therefore the triangles are in fact congruent. So let's look for my 3 facts that are equal. Well, there's some pretty obvious things. We are told that those two sides are equal, and we are told that those two sides are equal. So that's always a good place to start with what we're told. So NQ is equal to PQ, and my reason is given. So as soon as something is actually indicated on the sketch, then your reason is given. So the other pair of sides I mentioned was NY and PY, and also given. Now it doesn't look like there's anything else indicated. However, we need to be alert to the fact that this line here, YQ, notice, YQ, is in both triangles. So it's a side that's shared by the two triangles, and obviously it's the same line. It has to equal itself. So YQ is equal to YQ, and my reason is common. You may just write YQ as common as your third statement. That's also fine. Now, something I need to just point out. On the left-hand side of my proof over here, we're mentioning triangle NYQ first. So NQ, NY, YQ. NQ, NY, YQ are all on the left because triangle NYQ is on the left. Triangle PYQ, which contains PQ, PY, and YQ, PQ, PY, and YQ, must all lie underneath. So all the information about triangle PYQ is on the right because triangle PYQ was stated on the right. We now need to just fill in at the end what the case of congruency was. Now you can clearly see that all 3 statements are pairs of sides. So my case of congruency is side, side, side. In my next example, the two triangles don't touch each other, so we can only rely on the information that is given in the picture. I've gone straight to actually writing down the answer for you because it's much faster. You'll notice that in each triangle we're given a 10 centimeter side, so we can state that AB is equal to XY, and that information was given. We're given an angle of 75 degrees, so angle A is equal to Y, and again given. We're also given an angle of 65 in each triangle, so angle C is equal to angle Z. Now this is clearly a case where I have 1 pair of sides and 2 pairs of angles. Now remember, very, very important, the side, when there's one side and 2 angles, the side needs to be in the same position in both triangles. So you'll notice in this triangle the 10 is opposite the 65. And here again, the 10 is opposite the 65, which means that your sides are in the same position. We call that corresponding positions, which means I can use the case of side angle angle. So we just finish off after stating that the triangles are congruent with SAA. Now don't forget, all the information on the left is about the triangle first started with on the left. All the information on the right matches triangle YXZ because it's on the right. Okay, so the third and final example. Again, we've got two triangles that touch each other, but I want you to be careful here. A common error is to say that these two angles are equal because they're common. Absolutely, these two angles are equal, but they're certainly not common. C is a common vertex, but it is not a common angle. Remember, the angles are actually BCA and ECD. Again, we start with our layout by starting with our statement about the two triangles that we're working in. We're working in triangle ABC, which is the one on the left, and triangle EDC, which is the one on the right. Now, in this case, we're given two pairs of matching angles, matching sides. So let's start with those. BC is in the triangle on the left, so we're going BC, and that is equal to DC, and we know that because it's marked on the sketch, which means my reason is given. Again, AC is marked as being equal to EC, and that is also given. Now remember, just now I said that we have the two pairs of, a pair of equal angles because they are vertically opposite angles. So angle BCA is equal to angle ECD. And my reason is vert op angles. Okay, again, make sure that your order here is correct. So A is this angle over here. Now it should be pretty obvious that if I pick up the right-hand triangle, I'm going to need to rotate it to get it to fit on the left-hand triangle, and A will match E. So if A comes first here, E comes first there. It should be pretty obvious too that angle B over there would be lying with D on top of it. So if B is second, D is second. And then lastly, the C's match because they're the last angle of the triangle. Now I've got two sides and an angle. Now remember, two S's and an A is only allowable if the angle is between the two sides. So very important, you've got side, angle, side, side, angle, side. The two angles are between the marked sides. So SAS is my case of congruency. Now please remember, congruency is a critical tool that you need in your toolbox for future geometry. You need to be able to use it quite comfortably, and you need to be able to identify very quickly if two triangles are indeed congruent or not.